So this week we're going to talk about greedy algorithms. Just like divide and conquer, this greedy algorithm is not a stranger to us. We have encountered in the fundamental course several algorithms that are greedy. Can you name one? Like Dijkstra for finding the shortest path, right? Or like Kruskal for finding the minimum spanning tree. So basically, greedy algorithms are used to solve a kind of optimization problems. Optimization means to find the best solution of something. So first of all, we must define what being the best means. So usually we have a so-called optimization function with some constraints. Solutions that satisfy the constraints are called feasible solutions, so they are possible. A feasible solution for which the optimization function has the best possible value is called an optimal solution. So the greedy method is to make the best decision at each stage under some greedy criterion. For example, to find the minimum spanning tree, one stage is defined to be collecting an edge. So we collect the edges one by one, step by step. And we must collect the edge that has the minimum weight. So the weight is the criterion, and being minimum is what we call the best. A decision made in one stage is not changed in a later stage, so each decision should assure feasibility. So what does that mean? Again, for example, in the minimum spanning tree problem, once we decide to collect this edge, it will not be deleted from the solution set later. So there's no way to undo anything, and therefore we must make sure that each step is done correctly with no mistake. So in other words, we must check the constraints before we decide to collect or not to collect an edge. So for the minimum spanning tree problem, the key constraint is what? Is that this edge must not cause any cycle in the current partial solution, right? So that's what it means by saying that each decision should assure feasibility. So basically, greedy method is quite simple and works this way. So first of all, we're going to solve a problem step by step or stage by stage. And secondly, we try to be greedy at each stage. But be careful here. Greedy algorithm works only if the local optimum is equal to the global optimum, and greedy algorithm does not guarantee optimal solutions. The local optimum means the best decision for the current step. So it's local. Global means the overall problem, and they are not necessarily the same, meaning that what's the best for this step is generally not the best for the final solution. So, and if that's the case, and since we cannot undo any decision with greedy method, it will not work. So greedy algorithm works only if we are lucky when they are the same. On the other hand, even though it doesn't work, it generally produces solutions that are very close in value, so-called heuristics, to the optimum, and hence is intuitively appealing when finding the optimal solution takes too much time. So what does it mean? Heuristics, in Chinese we say 启发式的. A heuristic algorithm is 启发式算法. Still have no idea, right? It means that if it's too hard to find the real optimal solution, let's just find one that is sufficiently good. Not necessarily the best, but good enough. That's heuristic. Okay, so for example, if the only way to find the real best solution takes like exponential time, people would usually turn to greedy method, which can find some solution in a much faster speed. And at the meantime to prove that this solution is good enough. So greedy algorithm is usually quite simple to implement and with pretty good time complexity. And the trickiest part is to decide under which criterion that we should be greedy.